Hi, everybody. I would like to greet you and also wish you good luck and success in your new academic year. I promised that I'm going to share some videos related with some solutions of different tests which are going to be or usually seen in exam, in final exam, the ninth grade. Also, the 10th, 11th grade also can use these tests. So I'm talking about the test collections, Bornik test of Mathematica, British WhatsApp 2020's year, and I would like to give some explanation today to the topic, which is natural numbers. So we are going to talk about natural numbers, which is on page 2, and actually we are going to speak about some necessary solutions. But the principle is like that. When we start with when we do some solutions, when we do some exercises, uh, the first I do, the next one is usually done with you because you have to also apply the skills that you learn in your study. So first of all, I would like to start with exercise 1. So in exercise 1, you can see from the test book that it's written that which of the following expressions is odd number if n is odd and m is even. So what does it mean odd and even? First of all, let's try to understand which numbers we call odd numbers. Odd numbers are the numbers which are not divisible by 2, or we cannot divide them in two pairs. So 1, for example, number 1, 3, 5, they are natural numbers which are odd numbers. But also they can be even numbers. Even numbers are the numbers which are divisible by 2. For example, 2, 4. I'm talking about the nature of numbers. That's why I start with 2. 2, 4, 6, and so on. You can see that these numbers are divisible by 2. Then they are called even numbers. So we have got here different expressions in this test. So for example, we have such an expression in A, m times m plus n. You can see here that m is even, n is odd. We can take any number, for example, m is 2 because it's even, and here 2 plus n is even, let's suppose, for example, 3. So in this case, our expression will be 2 times 5, which makes it 10. So we get even number. It means that it doesn't satisfy our condition because we are taught to get the odd number in the end. So actually, in this case, if we check all the answers, we are going to get C, m plus n. For example, if m is even and n is odd, for example, n is 2, n is 3, then the answer will be always odd number. So in exercise 1, we get C. The correct answer is C. Let's continue to the next one, which is number 2. Number 2 says that we are given a set of numbers 9, 11, 21, 29, 32, 95, and 127. So it's written here how many of these numbers are prime numbers. So prime numbers are the numbers. There are two types of numbers. If we divide numbers in two parts, we can get prime numbers and composite numbers. So prime numbers are the numbers which are divisible by 1 and by the number itself. So the number is divisible by 1 itself. For example, 3 is divisible by 1 and itself 3. 5 is of course divisible by 1 and by 5. The numbers which have got more than 1 itself, so more than 1 divisor, yeah? 1 itself plus some other divisors. For example, number 4. 1 is divisible by 1, by 2, and by 4. You can see. Or maybe number 6 is divisible by 1, by 2, by 3, and by 6. So these numbers are composite numbers. These numbers are prime numbers. So in this case, what happens? Prime numbers, we are looking for prime numbers among these numbers. So obviously, if we take these numbers, so obviously we can see that there are numbers which are prime and there are numbers which are odd. So we have to select them, distinguish them. But how we are going to do it? We are going to use the divisibility test also. So in such exercises, it's better to use divisibility test. But let's start from 9, number 9. Number 9, we are looking for, again, for prime numbers. Number 9 is divisible by 1, by 3, by 9, so we can delete it. Number 11. Number 11 is odd number, but it's also prime number because it's divisible by 1 and by 11 only. It doesn't have any other divisor. So we know 21 is divisible by 1, by 3, by 7, by 21. So we can skip it out. 29 is a prime number because it's divisible by 1 and by 29. It doesn't have any other divisor, so we leave it. 32, again, you can see the number ends with an even digit. So in this case, it's 2. In this case, the number totally even. So there is a property that if number ends in an even digit, then it is even number. So actually, we can skip it off because even numbers are composite numbers because they are divisible at least by 2, except one number. So you should remember that 2 is a prime number. It's even number, but it's prime number. So do not forget it. So number 95. Number 95 ends in 5. We know that all the numbers that ends in 5 or 0, they are divisible by 5, so we can skip it. The number 127, you can check by divisibility test that it's not divisible by anything, so any number. So actually, it's also a prime number. So there are 3 such prime numbers, which says that the answer is 2B. So answer is 2B. So 3 is the same thing as number 2. So we go to number 4. In number 4, it's written how many thousands are in the number 53070. So actually, it is 530. When we read it, if you listen carefully, you can see that when we read it, it's 530,070. So we can be sure that it's 530,000. So like this, 530 with 3 zeros. You can see 3 digits. So it's kind of 500. So there are 530,000. It's 4A. So the correct answer is 4A. Next one is 5, which is the same as 4. So we go to number 4, number 6. Which of the following statements are incorrect or are false? it's written here, произведение четное, нечетное число, нечетное число. So if we have, for example, m even number and n odd number, it should be its product is said to be odd number. So this is a statement. We have to check, we have to verify whether it is correct or false. So actually what we can do here, the best way is to check such statements is to take the numbers, because it makes us lose less time. So it doesn't allow us to lose time, which is very precious thing when we do exams. So for example, m is even, is 2, n is odd, is 3. Let's check. 2 times 3 is 6. We see that we get an even number. So our statement is false because it's even number. We get even number. You can check any other, for example, 4 and n is 5, for example. It's going to be always even number. So our statement is not true. So 6, 8. 7 is the same fact as A. So we are talking about now 8. Which of the statements, again, which of the statements is incorrect or false? It should be B. Why? Because разность натуральных чисел, натуральное число. So difference of two natural numbers. Again, natural numbers is a natural number. Let's take two numbers, for example, two natural numbers, 3 and 7. Let's see their difference. It's not specified which difference. That's why it's we have to take we have to consider the statement in general. So 3 minus 7. Let's see, it's minus 4. You know, little number minus big numbers, it makes it minus 4. Minus 4 is not natural. So actually, what we get, we come up to a conclusion that 8b is false. That's what we have been required to find. Number 9 is the same as A, so we don't touch it. Now we go up to number 10. Какое изражение четное, если m и n нечетное натуральное число? So m is odd, n is odd. Which of the following expressions are said to be odd, even? So we have to focus on even results. So we have to see that if the result is even or not. So actually, you can check at 10D, m plus n. For example, let's take odd number 3 and 7, another odd number. We can say it's 10. It's always like this. You can take another number 5, 1. So it's going to be 6. So two odd numbers, when you add two different odd numbers, you're going to get even number. The same numbers also, if you add two same odd numbers, you're going to get even numbers as a result. So this is the property that you should always keep in mind. So 10D. You can check other answers for the validity, so you can check it for being sure that it's again D. So 11 seems to be the same. Number 12 is written here. Сколько пар взаимно простых чисел среди чисел? So how many pairs of relative prime numbers? So we are going to take the relative prime numbers. Which numbers we have? 4, 8, 3, 13, and 26. The thing here is that actually which numbers we call relative prime numbers. Relative prime. So these are the 9 numbers which have got only one common divisor. It's number 1. For example, if two numbers are divisible only by 1, they don't have any other common divisors, then these numbers are called relatively prime. So you have to pay attention that these numbers itself can be composite. For example, let's see let's take here number 4 and 13. You can see here that in this example that 4 is composite number because it's divisible by 1, 2, and 4. But 13 is a prime number. It's divisible by 1 and 13 by itself. It doesn't have any other divisor. So in this case, what happens, if we consider them commonly in pairs, then in this case, we can see that they have got only one common divisor. It's 1. They 2, 4, and 13 does not correspond. They are not common. But 1 is common. So that's why 4 and 13 is considered to be the relative prime numbers. You see, 4 is itself composite, but it's considered to be together with 13 relative prime. Let's check. Let's look at the pairs. 4, 8. 4, 8 is not relative prime because they have got other common numbers. They are both divisible by 2. So we cancel it, yeah? 4, 3. 4, 3, they are relative prime because they don't have any other common divisor than number 1. So we take this pair. 4, 13. You can see 4, 13 is also, as we explained here. What about 4, 26? What we can say about 4, 26? At least they are divisible by number 2. So they don't have a common divisor, only 1. They have other common divisors, so it's going to be, they are going to be not relative prime. So 4, 26. Let's go to another one. For example, 8, 3. What you can say about 8, 3? 8, 3 is also relative prime because they are divisible both by only 1. At the same time, 8, 13, the common, again, their common divisor is only 1. And 8, 26, they're again common divisor. But you can see that, well, 8, 26 should not be considered here because, you know, it's kind of, they have kind of many other divisors. At least they are divisible by 2. So we don't consider them. So it's going to be 8 and 26 should not be considered. Let's go forward. 3 and 26. Again, they might be relatively prime because they don't have common divisor. They are not divisible by any other number than 1. And 3, 13. 3, 13 is also a relative prime. Okay. What about 3, 13? What about 13, 26? This is the remaining final numbers. 13, 26. Again, 13, 26. You see, 26 is divisible by 13, so they have more than one common divisor. So we should leave it off. So what we have here, 1, 2, 3, 4, 5, 6. So there are 6 relative prime numbers which are corresponding to our answer. So 12b should be taken as the solution here. So 13, 14, and 15 are considered to be the same type. So in those exercises, it's also asked us to find the common divisors, meaningfully to find the relative prime numbers. So we are coming back to number 16. We know that 7a minus 3 squared is odd number. It's odd number. And a is a natural number. A is a natural number. So which of the following should be even number? So we are looking for even answer. The answer should be even. First of all, in order to answer such questions, we have to look at the nature of A. So what type of number is A? It's odd or even, because it's very important to solve, because our answers are also with odd or are also with A. So they all our expressions include number A. So we are going to have here, for example, let's see if it is odd number. How we can get odd? Let's check A. For example, let's take A is equal to 1. If A is equal to 1, so 7 minus 7 times 1 minus 3 is going to be 4. It's even number, so it falls down. Now let's take A is equal to 2. So when A is equal to 2, so actually 7 times 2 minus 3 is going to be 14 minus 3 is 11. So actually it corresponds to what we are looking for, because the result should be odd. 11 squared is odd. So if 11 squared is odd, so this expression is 11, this expression is odd. So actually we get odd when A is even. So you see, so we get to conclusion that A is even. And we can take any even number. For example, it could be 2, 4, or something. So let's take 2 and check the answers. We are looking for, again, even answers. So 4 times, let's check A. Let's check A. 4 times 2 minus 3. 8 minus 3 is going to be number 5. It falls down. 2 squared minus 1 is 4 minus 1 is going to be 3. So it's again odd number. See. 2 squared plus 2 plus 1. So it's going to be 4 plus 2 plus 1. So it is going to be 7. So it's again leaves out. So D, let's check for D. 2 cubed plus 1. So it's 9. So we don't consider it. It also falls. These are false answers. We have the remaining E. So seemingly it should be the correct answer. Let's check. 5 times 2 plus 2, 10 plus 3 is 12. So actually 12 is an even number. So it's well suited by our answer. So 16E. So again, what we have done here, we first found the number A. What type of number A should be? It should be even or odd. And then we found out that this is an even number. It's, for example, it's satisfied by 2, by 4, and by 6, and so on. So we take any even number, preferably small number too. So we put in the answers and check. But beware that there are other ways. So you can, if you have some other ways here, they are also welcome. There are, of course, other ways to check. We can prove it by general, but it's beyond the scope of this test, because the tests usually require some approach with less time. So the results should be achieved with less time. So we shouldn't use complicated proofs in such exercise. 18, we need to find x plus y plus z. If we know that xz, you see 2-digit number, times 4yz is 3-digit number, equals 7344. So actually, we get 4-digit number in the end. Let's start our analysis. So we have to do here some analysis, some research. Let's look at x. First of all, let's look at this. Can it be number 2? Let's see. Can it be number 2? If it was number 2, then this number should not start with 7. It should start with some 8 something, because at least 8 something, because it is 2 times 4. You see, 2 times 4 is actually 8. So it's beyond this number. It's over this number. So x cannot be 2. Obviously, x cannot be 3. X cannot be 4. So what x can be? X can be 1. And you should be aware that x cannot be 0 also. 0 cannot be considered here because the two-digit number cannot be 0. You cannot say 0 to like this two-digit number. It should start from 1 and end with 9. The two-digit numbers. Again, so we know that x is 1. Now let's come up to z. Z we can define by the final number. Our final number is 4. Now let's think which numbers can give us product 4. So it can be, of course, if z equals to 2, so z equals to 2. 2 times 2 is 4. Or z can be equals to 8. You can see 8 times 8 is 64. So again, it ends with 4. So ending with 4 numbers that you multiply by itself, the number you multiply by itself is either 2 or 8. So let's check these two numbers. Let's suppose it's 2. So if it is 2, we know that x is 1. Then it's going to be 12 times 4y 2 equals 7344. Now let's calculate. Let's do here some trick. Yeah, let's divide 7. Let's divide 7,344. Let's divide by 12. Yeah, if we divide it by 12, so we are going to get this number. Obviously, this number should start with 4. So we have to be sure that our number should start with 4. But however, if we divide it, we can be sure that we are going to get 612. So you see it starts with 6, but our number starts with 4. So number 2, z equals to 2 falls out. Now let's check z equals to 8. So obviously we need to check 18 times 4y 8 equals to 7344. Again, this time we divide by, let's divide by 18. So it is going to be, let's divide. It's going to be 408, 408. So actually we get 4y8 equals to 408. So from here we can see that y is 0. So which results we got? We got, let's see, x equals to 1, y equals to 0, and z equals to 8. So if we add them in this expression, 1 plus 0 plus 8 is going to be 9, which makes the answer 8. So 18. Well, guys, I'm stopping here. You're going to see this video in the YouTube channel, in my YouTube channel, and I will continue the next, in the second video. We'll continue the nature of numbers in English. So do not hesitate to subscribe to our channel. You're going to get more alerts, and you're going to get more videos throughout the week, which will be useful for you, not only for the exam, but also for your later maths. Okay, see you in our next videos. Take care. Bye.